Hello and welcome to the introduction for this course. What are the course requirements? You need a computer and internet connection to follow along with this course. Who is this course for? This course is for anyone who wants to learn something new. What is the course format? The format of the course is video. Hello there. In this video, I'll be showing you step by step how to download and install SQLite on your computer. The link to the download page is displayed on the screen. So I'm heading over to that link so we can begin the download. So this is the download page for SQLite. SQLite provides various versions for various platforms, for example, Windows, Linux, and Mac. So you should choose the relevant operating system download that you have got. I will be illustrating on a Windows-based computer. So I'm just going to look through the various download options here. We've got Android here, we've got Linux, we've got Mac OS, and then we've got Windows. And the one I am going to go for is this one here, which includes a bundle of command line tools for managing SQLite database file. This includes a command line, which is a shell program. So that's the one I'm going to go for. So I'm going to click on the download link to begin the download. It's 1.6 megabyte in size. So that's the download there. I'll just give it a few minutes to complete. So let me browse to the location of the downloaded file, and it's in my downloads directory. So that is my downloaded file here. And now we can progress with the installation. So we are not really installing. We're not going to run any installation file as such. What we're going to do is extract the content of this file into a directory. So it will extract into its own directory. And then within that directory, there should be an executable that you can reference SQLite from. So depending on the software extraction tool you have, I am using WinRAR. That's the WinRAR icon. WinRAR is free to use. So if you haven't got it, you can download it for free, or if you're using other software extraction tools, feel free to use whichever one you're comfortable with. So I'm just going to extract this inside the directory that downloaded it. So I'll right click and click on extract here. So it will extract into the same directory. So this is what it has extracted. If I click on it, you can see these are all the files it has. It has 3 files, and we have this SQLite 3, which is the actual executable. So what I am going to do, I'm just going to go back one to the actual folder here. I'm just going to rename this folder to SQLite. I just get rid of the other bits and pieces. And what I'm going to do, I'm going to relocate this folder to my C drive. So I'll right click, copy. You can copy or you can cut if you wish to, whatever you want to do, and then paste it in the root of your C drive. So this is my C drive here, and these are the files in my C drive. So I'm just going to right click and paste it here. So I pasted it in the root of my C drive. Now to test, to make sure that I have got SQLite accessible from my computer, I need to open up my command line, or if you're on a Mac, you use your terminal. So I've got my command prompt open. So I'm just going to navigate to my C drive where I've got the SQLite directory that I copied to. So I'll do cd ... which means move back 1. I press enter, it takes me further back. cd ... and that will take me another level. So now I'm going to cd into the SQLite folder. Okay, so now I can access the SQLite folder. What I need to do is just type in the command SQLite 3 and press enter, and that will access the executable. So you should see something like this. All right, so if you can see this, it means that you are able to interact with SQLite. So what you can do if you want to find out the various commands that SQLite has, you just do a dot and type in help and press enter, and that will show you the different commands available. So if you just read through, you can see this is archive, you use to manage SQL archive, backup, and so on. So just read through the various commands are available that you can use in SQLite just by typing in this command, just by typing in help after the SQLite, and that will give you access to all these commands. So feel free to read through them at your own convenience. Now, if you want to exit SQLite, what you do, you type in a dot, type in quit and press enter, and that will quit SQLite application. So that is it for this video. In this video, I showed you how to download and kind of install SQLite. We didn't really install, but we extracted the files and we were able to interact with the SQLite executable via the command prompt or command line. Thank you for watching. Bye for now. Hello there. In this video, I'll be walking you through how to install SQLite Studio. So what exactly is SQLite Studio? SQLite Studio is an SQLite database manager. So you can use it to interact with SQLite databases. You can also use the SQLite 3 command, which is useful, which is a command line shell, but there'll be times where you want to interact with the database using a graphical user interface, which is what SQLite Studio is. So let's take a look at some of the features that comes with SQLite Studio that makes it attractive to use. It is portable. What that means, you don't need to install or uninstall. You just download, you unpack, and then you run. It is also intuitive. It has an intuitive user interface. It is powerful, light, and fast. And it is cross-platform. By cross-platform, it will run on Windows, it will run on Linux, Vista, Macs, and most operating systems. So the key operating system it will run on: Windows, Linux, Macs. It is also very useful. You can use it to export to various types of formats. For example, you can use it to export SQL statements, comma separated file, which is CSV. You can export HTML, XML, PDF, JSON files, and so on. You can also use it for importing data from various types of format. And the formats could include CSV. You could even use it to import custom text files, which could include regular expressions. Another feature is that SQLite Studio is completely open source and free. So it is free to use. Open source meaning it allows various developers to contribute to make it better. You can also configure it. So it's configurable. So you can configure it with various colors, fonts, and shortcuts. So that's what SQLite Studio is. To download and install SQLite Studio, we need to go to the link that is displayed on the screen. So I am on the download page for SQLite Studio. So depending on the operating system you have, you choose the relevant download link. So I'm going to be downloading it on a Windows-based computer. So you've got options here. You can download the various links. These are the links here. I'm going to be downloading the installer. So there is a Windows installer, which is what I'm going to use. So I'm going to click to download. So that's my download. So my download has completed. So I'm just going to double click to run the installation. So I'll give it a few minutes to launch the setup. So is launch the SQLite setup. So I just click on next. I'll just minimize this so we can have the screen here. Now here it says register the following file extensions with SQLite Studio. I don't want to do that. I'm going to uncheck that. The reason being, I have got other database systems on my computer, so I don't want them all linking to SQLite Studio because of this DB extension. So I'm going to uncheck that for me. And this is the directory is going to install it to. So I'm going to click next and just click next and click install. If you get a Windows prompt, just press yes to continue. We'll give it a few minutes and it should say completing the SQLite Studio wizard. You can leave the check mark on there and click finish, and that will launch the SQLite Studio. So give it a few minutes to launch the application. You get a prompt to choose your language. You can click on the drop down to see the various languages. If you're happy with that, just click OK and it will launch. So this is basically what the interface looks like. So that is it for this video. In this video, I walked you through the download and installation of SQLite Studio, which is a GUI. GUI stands for Graphical User Interface, which can be used to manage SQLite database. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be going through some basic database concepts. We'll begin with the database, what a database is. A database basically is a collection of organized information or data that is stored in a table. A table, on the other hand, stores information in rows and columns. So a table will store usually a collection of related data entries in columns and rows. This table here is similar to what a database table is. So the columns are horizontal. For example, this word terminology can be referred to as a column, and this word meaning can be referred to as a column. The rows, these rows are going vertical. So these database, table, columns, all these are referred to as row. So basically, this is how the table is structured in a database table. So you've got the columns going horizontal and the rows going vertically. Each row in a database table is referred to as a record. A schema is a collection of database objects. I will show you examples of this later on in the course. So any item is referred to as an object in a database. A database is an object, a table is an object, a view is an object. So these are all objects. So a collection of database objects housed in a container is referred to as a schema.
Primary key. A primary key is a unique identifier, such as your driving license number or your health insurance record. Is a unique identifier that is used to identify unique records. So no two people can have the same records. So you are able to enforce that using a primary key. A foreign key, on the other hand, is like a primary key, but not exactly. It is used to reference a primary key in another table. For example, if table A has a primary key and table B has a primary key too, so you can have the primary key from table 2 acting as a foreign key in table 1. Likewise, you can have the primary key in table 2 acting as a foreign key in table 1, or vice versa. So a foreign key usually is used to reference another primary key in another table, but primary keys are unique per table. You can't have two primary keys in one table. There are two other concepts I want to illustrate with you. We've got the relational database. A relational database is a database with related tables. Also, we've got the concept of relational database management system. It's referred to as RDBMS for short. It is the software that manages the databases. So examples of the relational database management systems are Oracle, Microsoft SQL Server, MySQL. There is a lot more, but I've just restricted my examples to these three. So these are the basic database concepts that you will come across when working with SQL. Hello and welcome to this video. In this video, I'm going to show you how to attach a sample SQLite database. I have already downloaded the database to make things easy for you. However, the database file is in a zipped or compressed format, so you will require a software extraction tool to unzip it. The sample database we are going to be using for this course is called the Chinook database, and you will need software extraction tool to extract the database file. There are various software extraction tools available. You've got WinZip, you got 7-zip, you got WinRAR. 7-zip and WinRAR you can use for free. WinZip I think you can use for a trial period. So if there are others that are not listed that you are comfortable with, please feel free to use them. Once we extract the database file, we are going to put it in the root of the local drive. So my local drive is C, that's the C drive. So I've already got a directory called SQLite, which my SQLite lives in. And I'm going to create another directory called DB inside that. And inside that DB is where I'm going to place the extracted or unzipped Chinook database. So the Chinook database that I'm going to extract, I'm going to dump it in a directory called DB. The following is a database diagram that illustrates the Chinook database tables and their relationship. The Chinook sample database is a good database for practicing with SQL, especially with SQLite. This diagram will also be available for you to download under the resource page for this lecture. There are 11 tables in the Chinook sample database. So I'm going to run through some of the tables here. The employees table basically stores employees data such as employee ID, the last name, the first name, and so on. It also has a field named reports to, which basically specifies who reports to whom. We've also got the customers tables, which basically stores customer related data. We've got the invoices and the invoice items tables. These two tables store invoice data. The invoices table stores invoice header data, while the invoice items table stores the invoice line items data. We've also got the artist table, which stores artist data. It is a simple table that contains only artist ID and the name. We've got an albums table. The albums table stores data about a list of tracks. Now, each album belongs to one artist. However, one artist may have multiple albums, as illustrated by the relationship in the diagram. We've got a media underscore types. This table basically stores the media types such as MPEG audio and AAC audio file. We've got the genre table, which stores music types such as rock, jazz, metal, hip hop, and so on. And then we've got the tracks table, which stores the data of songs. Each track belongs to one album. We've got the playlist and the playlist underscore track tables. The playlist table basically stores data about the playlist. Each playlist contains a list of tracks, while each track may belong to multiple playlists as illustrated by the relationship diagram. The relationship between the playlist table and the tracks tables is referred to as many-to-many relationship. The playlist underscore track table is used to reflect this relationship. So this is a basic diagram showing the tables in this sample Chinook database and their relationships. So this is the database, the Chinook database, sample database. As you can see, it's in zipped format. So I'm just going to extract it inside this same directory. I'm going to right click and go extract here, and that will extract the database. So this is the database file. Now what I'm going to do now, I'm going to copy this database file. I'm just going to right click on it and go copy, and I am going to copy that into a directory I created in my C drive. So this is my C drive here, and inside my C drive I've got a directory called SQLite, and inside this SQLite I'm going to right click and create another directory. I'm going to call it DB, and inside this DB I'm going to paste that database file. So this is the Chinook database that I pasted inside that. So make sure your directory is something like that. So you got the C drive, the SQLite, and then inside the SQLite directory we've got the database DB directory, and inside there is where I have placed the sample database called Chinook. So that is it for this video. In this video I showed you how to attach a sample database to SQLite. Thanks for watching. Bye for now. Hello and welcome to this video. I'll be showing you how to connect to a sample SQLite database. There are two ways you can do this. You can do this using the command line interface. So if you're on a Windows-based computer, you can use the command prompt. If you are on a Mac, you can use the terminal. The second method you can use to connect is via a graphical user interface tool. So any tool that has a graphical user interface for SQLite, you can use that to connect to the sample database. Before I go to my command prompt, just want to show you the location of the database. So this is the sample database, and you can see the path, which is on my C drive in a directory called SQLite, and also in a directory called DB. So that's where I'm going to reference it from. So the first thing I want to do is to navigate to the SQLite installation directory where the SQLite 3 executable is located. So to do that, I need to change directory. So I do cd and type in SQLite. So that is the directory, and I press enter. So this directory contains the SQLite 3 executable. So if I do a quick dir to see what's inside that directory, you can see the content of the directory. So I'm just going to type in CLS to clear the screen. The next thing I want to do, now that I'm inside the directory, the next thing I want to do is to use a command to connect to the sample database, which is located in the subdirectory called DB. All right, so which is a subfolder in the SQLite directory. So this is how I would connect to it. You type in SQLite 3. All right, you do a space, type in DB. That's the directory that contains the sample database, which is called Chinook. Type in Chinook, OOD.db. All right, and press enter. So it gives you this. Yes, once you get that, that means this flashing cursor means you can now issue commands to connect to the database. So I've already connected to the database, yeah, and it's waiting for further instructions. So what I want to do, I want to type in a command that will enable me to view all the tables available in the sample database. So to do that, I just type in a period or a dot and type in the word tables and press enter, and that will show me all the tables in the database. So you can see these are all the tables listed, which are 11 tables in total. So you've got albums, employees, invoices, playlists, and so on. So these are all the tables in the sample database. So this is one way of connecting to the sample database. So to exit this terminal, you just type in .quit, and that will exit. You can see it takes you back to the command prompt, and then I can just type in exit again to exit the command line completely. So the second way to connect is by using a graphical user tool. So I'm going to use a tool called SQLite Studio, which I installed in a previous video. So I'm just going to go to the location where it was installed. So it was installed in my programs files, and it should be, there should be a directory. There we go. You got SQLite Studio, and this is the application. What I want to do, just right click to save me going through this option to open it each time. I'm going to right click and just create a shortcut. I'll say create shortcut, or say send to desktop and create a shortcut. So what that would do, it will create a shortcut on my desktop. So let me look for the shortcut. So this is the shortcut it has created. So that makes it more convenient for me to access it anytime I want to. So to connect to the sample database, I'm just going to launch this SQLite Studio, and where it's got databases, I'm just going to click on it, and where it says add a database, I'm going to click on that. It tells me the database type, SQLite 3. So you can see it's flashing where to pick it up from. So I'm going to browse to where the database is. So let me just click on this folder here to take me to the location. You can see the location of the database. I'm just going to select it and click open. And here we've got a checkbox. If I want to keep this connection permanent so that I don't have to attach the database each time, I can leave that checked. By leaving that checked, that means it will automatically launch the database when I open up the application, the SQLite Studio. So it's up to you. You can leave that checked or you can leave it unchecked, and each time you want to connect, just do that. I'm going to leave it checked for now to make it easier to reconnect. So I'll click OK, and you can see here this is the database. If I click on it, it gives me all the tables. You can see all the tables in the database. So it shows that I'm successfully connected to the database. So to disconnect, I just right click and there's an option to disconnect. I just disconnect and exit out of the application. If I want to go back in, I don't need to reattach. You can see here it automatically connects to the database because I checked the option to keep that persistent each time I try to launch the application. So that is it for this video on connecting to the sample database. Thank you for watching. Bye for now. Hello, how are you? In this video, I will introduce you to SQLite 3 tool. The SQLite 3 tool is integrated into the SQLite database application. It allows you to interact with the SQLite database using command line shell program. So it interfaces with the databases, it interacts with it via the command line interface. It allows you to write SQL statements that you can use to interact with databases to perform various database operations. So how do you start the SQLite 3 tool? To begin, you need to change directory to the directory where you've got the SQLite. And then once you're in that directory, once you've changed directory, you then type in SQLite 3, and that will start the SQLite 3 application. So I have got my command prompt opened. So I'm just going to change directory to where I have my SQLite, and then I'll press enter. So now I'm in that directory. So I just need to type in SQLite 3 and then press enter, and that will start the SQLite 3 tool or application. So by default, an SQLite session uses the in-memory database. Okay, so therefore all the changes will be gone when the session ends. That's what it means. So any changes you make once the session is over, it will be gone. So once you've started it, it gives you can see this flashing symbol here. That means it's waiting for further instructions. So at this point, you can start issuing out different commands that you can use to interact with the SQLite database application. In this video, I gave you a brief introduction to the SQLite 3 tool, which comes integrated with the SQLite database application. So it's basically a tool that allows you to interact with the SQLite database application via the command line utility. Thanks for watching. Bye for now. Hello there, how are you? In this video, I'll be walking you through some commonly used SQLite 3 commands. The first command I want to walk you through is how to connect to a specific SQLite database. So first you need to change directory into where SQLite is, and then once you're in that directory you type in SQLite 3, you do a space. If your database is in a database directory, you specify that by typing db if db is the name of the directory, and then you do a slash and then the name of the database. So let's take a look at how to do that. So I have got my command prompt. So if you are on a Mac or Linux, you can do this on your terminal. So I'm going to type cd to change directory to where my SQLite is. And once I've changed directory, I'll type in SQLite 3. I do a space, and I know the database I want to connect to is located in a database directory, and the name of the database is called chinook.db, and then I'll press enter, and that connects me to my database. So that command attaches a specific database when you connect to SQLite 3. The next useful command is to show all the tables in a specified database. So before you can do that, you would have already connected to the database, and once you've done that, you just type in .tables, and that will show you all the tables in the connected database. So let's see how that is done. So we've already connected to our specified database. So in order to see the list of tables in that database, all we need to do is do a dot and type in the word tables and press enter, and that will list all the tables in that database. So you can see all the tables for the specified database listed with just that command .tables. The next command I want to walk you through is to show you the structure of a table. So if you have a table and you want to take a look at the structure, this is a command you would use. You use a .schema followed by the name of the table. So I've already got my tables showing here. So if I want to see the structure of a specific table, say for example the table called albums, I'll just do a .schema and then a dot, just to schema space, and then albums, which is the name of the table. That's the table here called albums. So if I press enter, that will show me the structure. So by typing in that command, it gives me a structure of the table, basically how the table was constructed. The next command I want to walk you through is how to save the result of a query to a text file. So this is how you would structure such a query or command. So you start off by specifying the output file. That is the name you want to call the text file. So in this example, I've called it albums.txt. So it's going to create a file called album.txt. And this is the query it's going to write. This is the SQL statement. So it's going to select title from albums. It's going to order it by the title, and it's going to limit the records are returned to 24 because it may have hundreds or thousands of records. I only want the first 24 records from that table based on this query. So this is just a sample query showing you how to save the results of a query to a text file. So from the previous command we ran, which was to show you the structure of a table. So you can see here this table called albums has got these columns: album ID, title, artist ID, and then it's got a foreign key. So what I want to do, I want to just query the title, and I only want the first 24 returned. So to do that, I need to create an output file where it will save it to. So I'll type in output. I like to do it in lowercase. I'll do output space, and I'll call the name of the output albums.txt, which means it's a text file. Then I'll press enter. Now I'll write my select statement. I'll do a select title. I'm selecting the title from the table called albums. So I'll select title, and I do from, type in from albums, and I'm ordering. So I'm going to sort the results by using the keyword order by. I'm ordering by the title, and I am limiting the records that are returned to 24. That means I only want the first 24 records returned. So I press enter to that. So what this would have done now would have created a file called albums.txt, and it would have just inside that file, it will dump the first 24 records from that table. So if you open up your directory where you've got your SQLite, you can see that it would have created a text file called albums.txt. So if you want to see the content of this file, you can just open it in a text editor like I have done here. So looking at the query here, it gives me the first 24 here from the query I have written. The next command I want to walk you through is a command that will show you the database in the current database connection. So the command you need to type is just a dot followed by the word database. So I'm just going to type in a dot and then the word database and press enter. And you can see here it's giving me the path to my current database. So that's my database called Chinook. It just gives you the path. The next useful command I want to show you is a command that will show you all the available commands that you can use in SQLite. So to do that, you just type in a dot followed by help, and that will list all the available commands and their description. So I'm just going to type in a period and type in help and press enter. And you can see here that gives me a list of all the available commands are available. You can see here we've already used this one called .output, which basically is used to send output to a file or whatever it tells you there. Okay, so it tells you the various commands here, and it gives a description on the right hand side. The final command I want to show you in this video is how to exit the SQLite 302. So you can either exit by typing in a dot exit, a dot quit, or a dot q, and that will take you out of the SQLite 3 tool. So to exit, I just do a dot followed by the word exit and press enter, and that will exit the tool. You can also use dot quit or a dot q. Once you've exited the SQLite 3 tool, you can exit the command line completely by typing in exit, and that will take you out and close the command line tool. In this video, I walked you through some commonly used SQLite 3 commands. Many thanks for watching, and bye for now. Hello there. In this video, I'll be showing you how to use the SQLite dump command. The dump command is basically used to copy the contents of your database or the tables into a text file. So if you don't want to copy your entire database, if it's just some of the tables or a specific table, you could use the dump file to achieve that. So the command you type is dot and then dump, and that will dump the content onto the screen. By default, if you don't specify an output file where the dump will go to, it will dump the entire data on your screen. So let's connect to our database. So we change directory to where SQLite is located. And once we're there, we type in SQLite 3 to activate the SQLite 3 tool. We do a space and then we'll specify where our database file is. Mine is in a directory called DB. I'll do a slash, and the name of the database is called chinook.db. So that's the name of my database. I'm now hooked up to my database. Now to use the dump file, you need to specify an output file where it will dump it into. If you don't specify an output file, it will just dump everything on your screen. So to begin, I'm going to specify an output file. So I'll do a dot and I'll type in output. I'll do a space and then I'll give the location for the output file. So I want it to go to C on my C drive where I've got my SQLite. I want it to go there, and I want to give it a name. I'm going to call it Chinook, which is the name of my database, and I'm going to add the backup so that I know it's a backup of my database. And I want it to be an SQL file, so I type in SQL. That's going to be the file extension. So I'll press enter. So by doing that, it means it's created that file for me. I can now issue the dump command to dump the content of that database into the file I have specified. So I just do a dot dump and press enter, and that will dump the contents of the database into this file called Chinook backup.sql, which is in this location I have specified. So once I've done to exit, I just type in a dot and Q. You can either type in Q to quit or exit, whatever. So I'm just going to type in exit and press enter, and that will exit the SQLite 3 tool. So now if I open the location, I should see a file with this name, and it would have dumped the content of the database into that file. So if I open up, so you can see here, this is a directory specified on my C drive. There's a directory called SQLite. You can see here, if I bring this here, you can see the path I have specified in my output. It has created it here. This is the backup. So if I now open that in my text editor, you should see the content of the database that has been dumped into. So I have now opened up that file in my text editor. So these are the content. This is everything in my database that I've dumped into this SQLite file. So without specifying an output file, it will just dump everything on your screen. So it's very important to dump it to specify an output file. So these are the content. This is what was dumped from my database. So this is everything. This is basically what my database contains. So I can use this file to reconstruct my database, just in case if anything happens and I lose my database, I can just use this file to rebuild the database. Okay, so it's kind of like a backup for my database. So I've been able to use the SQLite dump command to take a copy of my entire database. You can also take copies of specific tables within your database if you wish to do so. So you can also dump specific database tables. So let's do that. Let's first of all see what tables we have, and to see the tables we have, you just type in a dot followed by tables and press enter. And you can see it's giving me a list of all the tables. So let's say I want to do a dump of the table called albums, which is this table here. So what I would do, I will first of all create an output file. So I'll do a dot output, and I'll specify the location. It's going to be on my C drive, and I am going to create a file in my directory called SQLite, and I'm going to call it albums.sql. So this is going to be the name of the file that I'm going to dump the contents of this album table. All right, so I'll press enter. So it has created that file for me. So to do a dump, all I need to do is do a dot followed by dump dump space and then the name of the table, which is called albums, and I press enter, and that creates the dump. So to quit the SQLite 3, I just type in .q. Q means quit, and press enter, and that will quit that. So now if I now open that location, I should see a file there called albums.sql. So you can see the location here, and you can see the file here, which is the SQL text file I created using this command here by specifying the output. And if I open that in my text editor, you can see the content. So these are the contents. This is what it looks like. If I scroll, you can see here, it tells you that's the name of the table. This basically is the structure, gives you the structure, how the table was put together. And these are all the content. This is how the content was added to the table using the insert command. And it gives you various things, command that were used to put the table and the data together inside the table. So the dump command is quite useful, especially for backup and restoration purposes. In this video, I showed you how to use the SQLite dump command. Thanks very much for watching, and bye for now. Hello there. The select statement is the most commonly used SQL statement in SQLite and also in other database systems. So it is the main statement that you would use to query and retrieve data from a database table. As shown in the illustration on the screen, you can use the select statements in combination with other keywords. So I'm just going to run through some of the keywords I have used in this illustration. For example, the word distinct here means unique. So if you want to retrieve only columns that are unique, you use distinct. So the distinct here means unique. The from here, in all select statements, you must always have a from. The from is where you identify the table that you are trying to query the data from. Sometimes you may want to join data from more than one table. To do that, you need to use the join clause. So you add join followed by the table you're joining, and then the on here indicates the other table you are joining the first table to. And then where you have the where basically is used to act as a filter to filter the rows in the result set. So this where clause here acts as a filter. The order by basically is used to sort the result set. So anytime you see the order by clause in your select statement, you are trying to use that to sort the result set of the query. And here we've got the limit, count, offset. So you can use these clauses to constrain the number of rows that are returned. So if your query has several rows, you can limit the number of rows you want the query to return by using the limit and offset clauses. And here we've got the group by. The group by basically is used to get the group of rows into groups, and then you apply the aggregate function for each group. So group by really is common when you're using aggregate function. And then here we've got the having. Having basically is used after you have the group by. You then use the having clause to filter the groups. So these are some of the clauses and keywords that you may use in combination with a select statement to interrogate the database. So let's quickly write a basic select statement. So I have got my command line. So if you are on a Windows, you can use your command line. If you are on a Mac or Linux, you can use your terminal. So just navigate to where your SQLite has been installed. So I'll just type in cd means change directory, type in SQLite, and then type in SQLite 3, and that would get the database up and running. So once you get that, you can start issuing commands. So let's do a simple command. Type in select. We'll do some basic arithmetic or maths. So I'll press enter and say I enter 7 plus 7, and then always enter the semicolon at the end so that it knows that you have finished that line, and press enter. And you can see here it has returned a valid number of 14. So when you add 7 to 7, it gives you 14. So you can use it for all kinds of things. You can do additions, you can do subtraction. And one thing you can also use multiple expressions in the select statement. So let's see how you can use multiple expressions. So type in select and press enter. And say, for example, I do maybe 10 divided by 2. I'll do a comma, and I'll do 3 times 5. So the asterisk here means times. And I put a semicolon to indicate that I have finished. If I press enter, you can see the outcome. 10 divided by 2 gives you 5. And then you have 3 times 5, it gives you 15. So you can do all sorts of things using the select statement. So this is just a basic illustration just to show you what's possible with the select statement. Hello there. In this video, we are going to learn how to query all the data from a single table in a database using the select statement with SQLite. So this is what the syntax will look like. If you are querying all the data from a table, the asterisk represents all the columns in the table. So that means it will retrieve all the records, the rows and the columns from the specified table in the from clause. So let's take a look at how this works. I'll be using the SQLite Studio, which is a graphical user interface, to illustrate this. So this is my SQLite Studio. So I've already connected. So once you launch SQLite Studio, if you haven't already got your database showing, you can go to this database icon here and click on add a database. It gives you this interface, and just browse to where your database file is and just click OK. You can test the connection before just to make sure it all goes okay. So if you haven't got your database listed, that's how you get it populated. So now this is my sample database called the Chinook database, and these are all the tables in my database. For this illustration, I'm going to query all the records from this table called albums. So I'm just going to click on this angle here to expand so that you can see the columns. If I expand this, it will show you all the columns in that table called albums. It's got these three columns: album ID, title, and then the artist ID. So I have got a query window here. If you can't see this query window, just go to Tools and click on Open SQL Editor, and that will give you this interface. So to begin, you type in the word select, you do a space and type in the word asterisk. Just type in asterisk there, the symbol asterisk. By typing asterisk, you don't need to specify the individual columns. The asterisk will fetch all the records from all the columns. So just tab and then you type in from, you do a space, and then you specify the name of the table you're trying to retrieve all the data from. In our example, I'm going to be using this table called albums. So I type in albums to represent the table, and then I'll end that with a semicolon to indicate the end of that statement. And then I'll press this icon here to run the query, and you can see here it's retrieved the query. So these are all the records. It tells me here total rows loaded 347. So if I scroll down here, you can see there's a lot more, but it tells you the total rows that were retrieved. And here it gives you the time it took to fetch the data from the table. So this is how you can retrieve all the records from a specific table. In a production environment, this might not be an effective way because you may have millions or even thousands of records. You can see here I've only got 347. If you're in a production environment where you have thousands and thousands of rows, this writing a query this way will not be effective, because each time you're running this type of query, you put a slight stress on the database and the network. So in a production environment, you would normally pick out the columns that you want to query the data from. But I just wanted to show you, if you had a situation where you had to retrieve all the data from a table, then this is the query you would write to get or fetch all the data out of that table. So that's it for this video on querying all the data from a specific table. Thanks for watching. Bye for now. Hello there. In this video, I'll be showing you how to query data from specific columns within a single database table using the SQLite statement. So let's take a look at what a basic syntax for doing that would look like. So this is what a syntax will look like. So you type in the word select followed by the names of the columns. So if you want 2 columns, say you specify the first column and you separate each column from one other with a comma. So column 1, comma, then column 2, and so on. And in the from field, you specify the name of the table you are getting the data from. So let's see how that is done. So I've got my SQLite Studio, and these are the tables from the sample database we are using called the Chinook database. Or the table I'm going to be using for this illustration is this table here called tracks. So I'm going to expand it so you can take a look. It has 9 columns. So let me expand that. You can see all the columns from that table. Now, I don't want to retrieve all the data from all the columns. I only want to get data from specific columns. So this is how I would do that. So I type in select and then I do enter. And then I'll start specifying the individual columns I want to retrieve the data from. So I'm interested in the track. Let's say track underscore ID. So I'll do track ID, which is this column here, track ID, which is the first one. I'll do a comma and then I tab down. And then I'll add the name of the second column. There is a column called name, which is this column here. So I do a comma. I'm going to add a column called composer. So I type in composer. I do a comma. I tab for some reason. Okay, yep. Composer, make sure you get the name right. You can always check against the actual names of the column here. So we've got composer and that's it there. And I'm going to add one more, which is this unit price here. So I type in unit price. You don't need to add a comma if this is the last column. You only use a comma to separate individual columns from each other. So I've now selected the columns I want. So I'm going to tab down and type in the from keyword because I need to specify from what table I am getting these columns from. And the name of the table is called tracks, which is this table here. So now end that with a semicolon. So what this statement is saying here is that I am retrieving specific columns from this table called tracks. So I've got the track ID, which is this, name, which is this column here, composer, which is this column, unit price, which is this column. From is where I indicate the table I'm getting the data from. And I specify the name of the table, which is tracks. I specified it here. And then I'll terminate that statement with a semicolon, which indicates that I have finished. So I'm going to press this icon here to run or execute the query. You can see here it has returned a total of 3,503 records from the table with the columns I have specified. So if I scroll here, you can see I've got the track name, and then I've got composer, and I've got the unit price. So only the columns I have specified in my query have been returned in the result output. So that's basically how you retrieve data from a table if you want to select specific columns. So if you don't want to query all the data, you can pick and choose the columns you want, add that to your query, and then you can fetch the data from the specific columns you have specified. So that's it. Thanks for watching. Bye for now. Hello there. In this video, you will learn how to sort the result set that is returned by a SQL query using the order by clause. So SQLite stores the rows in a table in an unspecified order. What this means is that the rows in the table may or may not be in the order that they were inserted. So if column A was inserted first before column B or row B, it doesn't necessarily mean that they will come out in that order. So if you use the select statement to query data from a table, the order of rows in the result set from that query may not be in the specified order they were entered. However, you can sort the result set by adding the order by clause in your select statement. So this is how you would do it. You use the select statement to select the columns you want. You use the from to specify the table name you are fetching the data from, and then you use the order by clause to specify how you want to sort the data that is being fetched from the table. As you can see in the example query here, the order by clause always comes after the from clause. This is because the order by clause allows you to get the data first, and then it will then sort the result set from that query based on one or more columns in the order you have specified. So when you are ordering data or sorting the data using the order by clause, you can specify to sort the data in ascending order, which is ASC, or in a descending order, which is DSC. I have added an E. I missed out the E here in descending, so this is how you specify. If you specify in a descending order, that is from say Z to A, you use this. If you want to sort the result in ascending order from A to Z, then you use ASC, which means sort in ascending order. If you don't specify when you're using the order by clause, for example, if you don't specify if you want the records to be sorted in ascending or descending order, if you don't use any of these keywords, SQLite will use the ascending by default. So if you don't specify, it will sort the records by ascending. That is the default option unless you specify. In case you want to sort the result set by multiple columns, you have to use a comma to separate the columns. The order by clause will sort the rows using the columns from left to right. In other words, the order by clause will sort the rows using the first column in the list, then it will then sort the rows using the second column in the list, and so on. So let's see how the order by clause works. If you don't use the order by clause in your select statement, the results that you get back may not be in any specific order. So the table I'm going to use to illustrate is this table here called tracks. So if I expand that, you can see it's got 9 columns. So these are the columns. So I'm going to just select some specific columns from that table. So to begin, I'll type in select, and then I'll tab down and begin to select the columns I want. The first column I want is the name. So I type in name. I like to specify the columns in lowercase, and then you do a comma to separate each columns you are specifying. And I'm going to grab this column here called milliseconds. So I'll type in milliseconds, M-I-L-L, milliseconds. Okay, and I'll do a comma and tab and pick out the next column I want. I'll just type in album ID. We've got an album ID here, which is what I have specified here. So I'm going to leave it to these three columns for now, just to make things simple. And then I'll type in the from. The from clause is where you specify the name of the table that you want to use. So I'll do from, and I can do a tab here and just type in the name of the column, of the table, sorry. So the name of the table is called tracks, which is this one here. And now I can add my order by. So I'll do tab and I'll type in order by, and I'm going to order by the album ID. So I'll type in album ID, and I want it in ascending order. So that is from top to bottom. So even if I don't specify ascending, if I just specify order by and I specify the column, it will automatically default to ascending because that is the default. So now let me run this query by clicking on this button here. You can see I have got some error here. It's telling me one good thing about this editor, it will tell you when you go wrong. It can't identify this column here called milliseconds, so I must have spelled it wrong. So it's milliseconds, there's no E, so I get rid of the E there. So that should be okay. So let's run the query again. You can see the query executes this time because I got the name wrong. Always check the names of your columns when you specify them so that you don't get errors. All right, so it's returned 3,503 here. So you can see here it has filtered the records in ascending order. All right, so that ascending basically means from top to bottom, and it's done that using the album ID. So it's using the album ID. If you can see the album ID here, this is the column that we're using to sort the records. So you can see you've got one first, after one you got two, you got three. So focus on this line here where it's got album ID. That's where the sorting is. And then you can see it's in numerical order from top to bottom. So if you want to sort it the other way around from bottom to top, you use DESC, which stands for descending. So that is it for this video on sorting records using the order by clause. Thank you for watching. Bye for now. Hello and welcome to this video. In this video, we are going to learn how to use the SQLite where clause to filter the records that are returned from a query based on certain search condition that we specify within the query. The where clause will basically specify the search condition for the rows that are returned by the query. So let's take a look at what a typical basic syntax will look like. So this is what a syntax will look like using the where clause in a select statement. So we select the columns, we specify the table, and then we use the where clause. And after the where clause, you specify the condition that will be used to filter the records that are returned from the database query. So when you are evaluating the select statement that contains a where clause, SQLite basically, the way it does that, it checks the table first. So it will come here and check the table you're trying to get the data from. And the second thing it does, it evaluates the condition. So whatever conditions you would have specified in your where clause, it will evaluate that condition in the where clause in order to get the rows that meet the conditions you specified. And then finally, it will make the final result set based on the rows in the condition. So whatever rows match the condition you set in the where clause, it will return the records based on that condition. So let me illustrate a basic example of how the where clause works. So I'm going to use a table in my sample database called tracks. This table here, it has 9 columns. So I'm just going to select some columns from this table and then use the where clause to filter the records that it will fetch back from the table. So I'm going to start by typing in the select keyword. So I type in select, and then I will specify the names of the table, the columns. So I specify the names of the columns I want to use. So I'll say I'll pick the name table, name columns. So I'll type in name. I always like to specify the name of the columns in lowercase. So you separate each column by a comma. So I'll do a comma, and I'll select my second column, which is going to be composer. There's a column here called composer. That's going to be my second column, and I'll just select one more, which is the album ID. There's one here called album ID. That's it here. So I've selected 3 columns: name, composer, and album ID, and I'll tab. Now I need to specify what table the data is coming from, and it's coming from a table called tracks. This is a table called tracks. That's where the data is coming from. Now let me show you, let me run this query the way it is so I can explain the difference between using a where clause. So if I execute by clicking on this, you can see it's returned a total of 3,503 rows. Now I can limit this by using the where clause. So the where clause will filter the records that gets returned. So I'm just going to get rid of this semicolon here and do a tab, and I'm going to add a where clause to filter the records that will be returned based on the condition I'm going to set. So I'm going to say where album ID, well, album ID is equals to 1. So here I've set a condition that I only want the records returned that matches this condition, where the album ID here, you can see here, this is the album ID column, the different album ID here. I'll only want the records that match this criteria where they've got the album ID 1. I only want those records to be returned. So there will be a drastic drop in the records that was returned from this amount to the new amount. So let me run the query again. You can see here is only returned 10 in comparison to when I did not use the where clause. So the where clause is very useful to filter specific records from a database table. And you can here I've used the equals to. You can use different types of operators in the condition of the where clause. So you can specify where maybe something is greater than or less than and so on. So there are different kind of operators that you can use inside your where clause condition. So this is just a basic example to show you the power of the where clause. So the where clause will only return records that match the condition that you set in the where clause. In this example, I have set a condition that I only want the records whose album ID is equals to 1. Hence, you can see here in this album ID field, only the album ID number 1 is returned. So that's it for this video on using the where clause. Many thanks for watching. Bye for now. Hello there. In this video, I'll be giving you a brief introduction to some of the SQLite constraints. SQLite constraints are used to specify the roles for the data in a database table. Normally, you can create constraints when you create tables. So constraints can be specified when the tables are created with the create table statement. Also, you can also apply constraint after the table has been created using the alter table statement. So if you have a constraint that you did not apply when the table was created, you can apply it later using the alter table statement. Constraints can be applied at the column level within a table or at the table level. If you apply constraint at the column level, it only affects the column. However, if you apply the constraint at the table level, it applies the entire table, including the columns. Let's take a look at some of the commonly used constraint in SQLite. The first one is called not null, which basically ensures that a column cannot have a null value. So when you create a table, you can specify that the column or that field cannot be empty. You must enter a value for it. Another constraint is called unique, which basically ensures that all the values in a column are different, so they have to be unique. Another constraint is called the primary key. The primary key, in a way, is a combination of the not null and the unique. This is because it uniquely identifies each row or record in a table. For example, a social security number has to be unique for everyone, and you can set a primary key constraint on a column to enforce that. You can also have a foreign key constraint. A foreign key basically uniquely identifies a row or a record in another table. Another commonly used constraint is called a check constraint, which is used to ensure that all the values in a column satisfies a specific condition. Another constraint is called the default, which is used to set a default value for a column when no value is specified. So these are some of the commonly used constraints in SQLite. So normally you would apply a constraint either when you're creating a table using the create table statement, or after you've created the table. In that case, you use the alter table statement. In the sample syntax here, you can see this is a syntax for creating a new table, and you can see here I have specified some constraint here, which means that this column here has to have the primary key, which is what I've set here. That means any value that enters this column has to be unique. Also here I've got another constraint here called default. So constraints are quite useful to apply certain rules to the data in your table. So that's it for this brief introduction to SQLite constraints. Thanks for watching. Bye for now. Hello there. In this video, you will learn how to use the create table statement in SQLite to create a new table. The main function of the create table statement is to create a new table. So let's take a look at a basic syntax that can be used to create a new table. When creating a new table, you specify several attributes. So let me run through this sample syntax. The name of the table, when you're creating a table, the name of the table cannot start with the word SQLite. That's because the word SQLite is reserved for the SQLite internal use. So you can't call your table SQLite. In addition, you cannot create a table that already exists in the current database. And to avoid that, you can add this optional clause in your table create table statement. There's this optional clause here that says if not exist. So what that is basically saying that if the table exists, don't create it, only create it if it exists. So this optional clause here helps you avoid trying to create a table that already exists. You can also specify the schema name that the database is attached to, the database where you want to create the table, and then you give the table a name, and then you have an opening parenthesis, and also notice I've got a closing parenthesis here, and in between the opening and closing parenthesis is where you specify things like the columns that you want the table to have. So you can specify the column name. You can also specify the data type, that is the type of data that you want to store in the table. And you can add a constraint. For example, if you want to add a primary key constraint, you then add that as you are creating the table. So you can add that at the column level, or you can add a constraint at the table level. A primary key basically is used to uniquely identify a row in a table. However, if the primary key consists of multiple columns, what you might need to do, rather than use a column constraint, then you can use a table constraint instead of using the constraint at the column level. Notice here I've got without row ID. Basically, by default, a row in a table has an implicit column, which can be referred to as row ID, OID, or row or underscore row ID column. Okay, by default. So the row ID column basically stores 64-bit integer key that uniquely identifies the row inside the table. However, if you do not want SQLite to create the row ID column, you can specify that by adding this option without row ID. If you add that to the create table statement, it will not create a row ID for you. A table created with the row ID is going to contain a column called row ID within the table. Before you create a database table, it's always good to model the table to see what your table will look like. So in this illustration here, this is the table that I'm planning to create. So, and also when you create tables, it's good to have tables that have relationship with each other, and you can specify the relationship between tables using the crow's foot notation. They call it crow's foot notation because it looks like the foot of a crow, which is a popular bird. So you can see here it defines this different symbols defines the relationship that I have specified here between the tables that I'm creating. So using the crow's foot notation, you can apply relationship that exists between each of the tables. So the modeling here is for 3 tables. So these tables is going to have the following names. So we're going to have a table called groups, one called contact underscore groups, and one called contacts. Each contact has the following information. We'll have the first name, last name, email, and phone. Both the email and the phone number has to be unique, and to make them unique you have to apply a constraint to that. And also, in addition to that, each contact belongs to one or many groups, as illustrated with the relationship diagram using the crow's foot notation. Each contact belongs to one or many groups, and each group has 0 or more multiple contacts. So you can see the relationships between the tables have been illustrated using these symbols, which are illustrated here using the crow's foot notation. I'm going to end this part of the video here, and in the part 2 of the video we'll go ahead and create these 3 tables. Thanks for watching, and bye for now. Hello and welcome to the part 2 of this video, where we are actually going to be creating 3 tables using the SQLite create table statement. In a previous video I modeled the tables that we are going to create using the entity relationship diagram, which is known as the crow's foot notation. So I've used the crow's foot notation to illustrate the relationship between the tables that we will be creating. So let's go ahead and start creating the tables. So here I've added a statement that is going to create a new table called contacts. So notice the opening parentheses and the closing parentheses. So this table here that I am going to create using this statement, we have a few constraints here. Notice in this field called contact underscore ID, which is an integer data type, I've applied a primary key constraint. So to this column, what that means is that by applying a primary key, it makes that column unique. So the values in that column cannot be duplicate values. And here for the first underscore name and the last underscore name column, I have set the data type as the text storage class, and I've also set a constraint so that both columns cannot be null. So you must enter a value for those columns. So one of the processes is that once you create a table, eventually you have to insert data into the table. So at the point of insertion of data, these constraints will play a key role, because it will not let you get away with not inserting any values for the first name or the last name. Anything that's got a constraint will kick in when you try to insert data. Also, the email field here, the email column, it's got a text storage class data type, and I've set a not null and unique constraint. So that means the email cannot be null. You must enter an email value, and I've also made it unique, so 2 people cannot have the same email address. The same thing with the phone column here. I've applied a text storage class as a data type, and I've also applied 2 constraints, not null and unique, which means you must enter something as a record for a phone number when you're inserting data, and also the phone number has to be unique. So let's go ahead and create this table by executing the query. So I'll click on this, and if everything goes well, it tells you the query has run. If I refresh my table list, I right click and there should be a refresh. You should see the name of the table called contact. You can see here, that's the table I've just created. And you can see the columns here, which are these columns I have specified. So let's go ahead and create a couple more tables. So here I have added the query, the create table statement to create a new table, and I'm calling the table groups. So the table basically has just two columns here with group underscore ID, which has an integer data type, and I've applied a primary key constraint to that column. And I've also got another column here called name, which has a text storage class data type, and I've applied a constraint of not null. That means you must enter a value when data is inserted for this column. So let me go ahead and run the query, and the fact that I've got no error here means the table has been created. Again, if I refresh my table list, you should see a table there called groups. So if I expand that, you can see it's got two columns, group underscore ID and name. So we've got two tables created. Now I'm just going to create one more. So this is my statement I'm going to use to create another table called contact underscore groups. Now this table is going to have a primary key that consists of two columns, the contact underscore ID and the group underscore ID, these two columns. And you can see here I've specified the primary key constraint here, and I'm applying it to these two columns here. I've also got a foreign key constraint here on this contact ID, and that means it's referencing a primary key in another table, and it tells you the contacts table. So this foreign key is going to be related or referencing the contact underscore ID from the contacts table. You can see this contact underscore ID. That's what I'm referencing here with the foreign key. So you can see I've got a couple of foreign key here. That's the first foreign key, and that's another foreign key. Foreign key usually references a primary key column in another group. Sorry, I meant to say in another table. So anyway you have a foreign key, it is referencing the same column name, but that column is referred to as a primary key in another table. So you reference it using a foreign key from one table. So let's go ahead and execute this query, and we should get another table created. You can see no errors here, so that means it was a success. I'll just right click and refresh my table list, and we should have a new table called contact underscore group. There you go, contact underscore groups. So that is it for this video on creating tables using the create table statement. Thanks for watching, and bye for now. Hello and welcome to this video. In this video, I'll be showing you how to insert a new record into a database table using the SQLite insert into statement. So the insert into statement is basically what you use to insert new rows or records into a database table. So this is what a typical syntax would look like. So you type in the word insert followed by the name of the table, then in opening and closing parentheses, any column names that the table has, you have to put that between the parentheses and separate each column by a comma. Now, if any of the columns has a primary key ID, you can skip that because that column is automatically added on when you insert a record. And then here we have the values, and again the values you have to wrap it around parentheses, and the values have to correspond to the column names. For example, for column 1 here, If it's a name field, then the value you give here has to correspond to that, and so on. So it will make more sense once we start inserting some records into a table. I have added an insert into query here to insert a new record into a table I created in the previous video. The table I created was called contacts. It has 5 columns, and here you type in the word insert into, followed by the name of the table, which is contacts, and then in opening and closing parentheses you specify the columns of the table between inside the parentheses. So I've got the first underscore name, last underscore name, and I've got the email, and I've also got the phone. Notice I've not included the contact underscore ID. That is because this column is a primary key column, so it automatically SQLite automatically populates that column being a numeric number. So if I run this query, it will insert one record into the database, and this column called contact ID will automatically have the record ID of 1. So the values has to correspond to the name. So you can see here the first underscore name, I've given it the name of Johnny. When you are inserting text, you have to wrap it around quotes. So you can see I've got a comma here. The last underscore name, I've given it a value of cash. So Johnny corresponds to first name, cash corresponds to last name, and then this email address corresponds to the email, and this phone corresponds to that. So they have to match. So if I run this, it should insert one record. It tells me the query no issues. So now we can check that by running or doing a quick select statement. So I'll do a select, and I'll do star from, and the name of the table is called contacts. So now if I just select that and run it, okay, I'm getting an error here, which means I have done something wrong. Yes, I have. You notice my select statement, I've got an extra E there. So now I should be able to run it. I'm still, oh no, it's working now. You can see here it has inserted one record. You can see I didn't add the contact underscore ID column because it's a primary key. So SQLite automatically will populate this contact underscore ID column. But look at the ones I've added. Johnny corresponds to first name, Cash corresponds to last name, and then this corresponds to the email address, and that is the phone number. Some of these fields here I've got constraints on them. So when you have a constraint on a column, that means you must enter some value. If, for example, let me try and run another query. If I want to modify this and try and insert another record but leave a field out, for example, let's say I leave this field out and I don't complete that, and I try to add, let's change that from Johnny to Tony, and let's change that to a T. Now if I try to insert that record, I expect to get an error because I have not entered the value for this phone here. So let me run that. You can see here it's telling me incomplete input. So wherever you have a constraint, it means you must enter a value. If not, it will not allow you to execute the query. So I'm going to add another row to my table. So again, like the first query, I've just changed the values a bit. So I'm going to highlight that and execute. So it should have 2 records in there now. If I run this query, it should show me 2 records. You can see this field here as auto populated, so it's giving me contact ID 1 and that's 2, so that's Jane Doe and that's the email address and so on. So if you want to add several records, just follow the same process. I also created another table in the previous video called groups, so I'm just going to insert a couple of records into that table. So this is the table here. It has 2 columns, group underscore ID and name. I'm not going to add the group underscore ID because that has a primary key, so that will auto populate like this one did. So I'm only going to add this name column, which is this, and the values here will only correspond to the name. So I'll just highlight that and execute, and I'll do the same here. I'll highlight that and execute. So that should have inserted 2 records. So if I run this select statement on the groups table, I expect to see 2 records. There you go. We have 2 records here. You can see the group underscore ID was auto populated, and the name here I've got cash flow, and this one I've got accounts. So that's basically how you insert new records into a database table. Thank you for watching. Bye for now. Hello and welcome. In this video, you will learn how to update existing records in a database table. The SQLite update statement is what you use to update and modify existing records inside a database table. Whenever you have records in the database, there comes a time where records may change. Maybe if it's relating to last name, a lady may get married and may need to change her name to her married name and so on. So let's take a look at a typical syntax for writing an update statement. So you start with the keyword update and then after the update, you specify the name of the table you want to perform the update on. And then next you type in the word set. This keyword set is very important. This is what affects the change. So this is what you use to set the new value. You specify the name of the column that contains the value you want to modify, and then you have to, it has to be equal to the current value. So you look for what the value you want to make it to, and then you have the where condition. So inside the set word here is what you use to set the new value for the column you want to change the data. And then you specify a condition in the where clause. This is really important because if you don't specify a where condition, the update will be applied to all the records in the database, and I'm sure you don't want that, especially if you're in a production environment where you have thousands and thousands of records in some companies. You really do want to specify a where condition so that you only update the record you intend to. All right, so let me show you an example. Here I run this query here, which is a select statement on this table called contacts, which has these following columns here. And the record I want to update is the last name for this lady called Jane Doe. I'm going to assume that Jane Doe's got married to Mr. Johnson. So we're going to change her name from her last name from Doe to Johnson. So this is the query. Line 1 here, we'll type in update followed by the name of the table, which is contacts. Line 2 is what we use to set the new value. So we're setting a value for the column called last underscore name, and we're using the equals to set the new value. So the new value is Johnson, which is our new married name. And here on line 3, very important, we're setting a condition. So we're saying where the contact ID, contact underscore ID, which is this value here, is equals to 2. What that means is that it will only update the records that matches this condition where the contact ID is 2. That way it ensures that you only update the record you intend to update. So let me run that query And you can see here it would have done that. So if I run this select query again, that value should have changed from Doe. You can see here it's now Jane Johnson. It used to be Jane Doe. So that's basically how you update records in a database table. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, you'll learn how to use the SQLite delete statement to delete existing records in a database table. So the SQLite delete statement is basically used to delete existing records in a table. So this is what the syntax would look like to delete records from the table. So you start with the word delete, and then in the from field you specify the table name you are deleting records from, and then in the where clause you specify the condition for the delete to occur. It's very important that you include the where clause. If not, it will delete all the records from your table. So let's delete a record from a table, and the table I'm going to delete the record from is called groups. So this table has two columns, a group underscore ID and a name column. So before I do that, I always like to run a quick select statement to see what's in the table. So this is the records. The table has two records. So let's assume this record number 2 account is no longer required. In order to delete it, this is how I would construct the query. So I enter the word delete on line 1. Line 2, I specify the table that the record is going to be deleted from, which is groups. And line 3, I specify the where condition, which is very important, so that it only deletes record that matches the criteria. So you can see here the group ID is 2. So this is what I've said here, where the condition, which is the group ID, is 2. So it will only delete records that matches this group ID of 2. Without adding the where clause, it will delete all the records from your table, which is very dangerous if you have crucial data, especially in a production environment. So always put a where clause. So now if I highlight this and execute, now if I run this query again, I expect that record to be gone. So you can see here the record I deleted is gone. So just by using this simple statement. In this video, you learned how to delete a record from a database table using the delete statement. Thanks for watching. Bye for now. Hello and welcome. In this video, you'll learn how to remove a database table from a database using the SQLite drop table statement. So the statement is basically used to remove a table from a database. So let me show you how to remove a table from a database. So before I do that, I want to run a select statement so that we can take a look. So this is a table I want to remove. It's called groups. So all I'm on line 1 here, I'm using the drop table statement. So type in drop table followed by the name of the table you want to remove. And the table is called groups, which is this one here. So I'm just going to highlight and run that query. And if I refresh my table list, see my table list says 13. I expect that to change to 12 when I refresh. And the name of that table should disappear. You can see I haven't got a table called groups anymore. Just to confirm, if I run the select statement again, it should give me an error. It's telling me that that table does not exist. In this video, I showed you how to use the SQLite drop table statement to remove a table from a database. Thanks for watching and bye for now.